All right, you guys, this is section 2.3, and it is about standard form. In the last two sections, we've learned slope-intercept form, which was our y equals mx plus b, where we had our y equals x, and then the m and the b represented our slope and our y-intercept. The next format we learned was point-slope form, y minus y1 equals m times x minus x1, where we still had our y equals x, and we had the m that represented the slope of the line, and this time we had a point on the line, x1 and y1. Those forms are both really good to use when you're given information about the line, such as the slope, the intercept, or a point. Our next form is called standard form, and it is ax plus by equals c, where a, b, and c are not representative of something on the line, but more so what the line is representing. Notice we still have our xy equals, c some constant number, and the big idea of this format is a must be a positive number, can't be negative. That leader, this is our line leader, our leading coefficient. It must be positive, and it cannot be a fraction. So it must be positive and not a fraction. We're going to learn more about standard form and how to look at this format and know how to graph it, but also how to look at different scenarios of information and write an equation of a line. Turn the page. We're not going to do example 1, we are going to do example 2. You are given a little graph here. You need to draw an x and a y-intercept like what I have, where we have a vertical y-axis and a horizontal x-axis. And we are given the line 4x plus 5y equals 10. And we're asked to graph it. And you're like, well, I don't know the slope, I don't know a point on the line, like I literally have no idea where to start. And that's what I'm going to teach you in this example. We're going to start by finding the x and the y intercepts. Remember, an intercept is where we cross an axis. So the y-intercept is where we cross the y-axis, and the x-intercept is where we cross the x-axis. Once we find those, we can plot those points on their axes, and we can connect the dots to draw the line. Now you're like, well, how do we do that? And this one's kind of quite easy. If we want to find the x-intercept, we cover up the y. We pretend the y value doesn't exist. And if we just covered up that y value, I would have the equation 4x equals 10. If I just got rid of that y term, and then I could solve that by dividing by 4 on both sides. And 10 divided by 4 is 2.5, so my x-intercept is 2.5. Now if I wanted to find the y-intercept, I would just switch that around. This was a 5y when I erased it. We completely would just cover up the x part of the equation, and we would have 5y equals 10. I would divide by 5 on both sides. 10 divided by 5 is 2. So my y-intercept is 2. And we found that just by covering up the different pieces of our equation. So now I can plot those two intercepts, and that is my second step. So at x is 2.5, which is going to be between 2 and 3, I'll plot a point. At y equals 2 on the y-axis, I'll plot a point. And then all I have to do is connect those dots and extend it going on forever. And there we go. I just graphed that line. And the only thing we did was have to cover up parts of our equation. We did it. Let's do another example together. Oops. Here we go. Maybe it's going to let me scroll. What's happening? There we go. Okay. This is some information we need before we can do example 4. Here's our scenario. Tamira is making trail mix. She has $40 to spend on a mixture of almonds and cashews, as we can see in this image, and she wants about the same amount of almonds and cashews. How can she determine how many pounds of each kind of nut to buy? And then it says, write and graph an equation to represent the situation. So if we were to use point-slope form or slope-intercept form, we don't know a point or a slope or anything. That wouldn't be a good format to use. But we can use standard form, where we have some number a next to some variable x plus some number b next to a variable y equals some number c, some constant term. So this is where we're going to put these pieces of information together. We know almonds is $8 a pound from the image that I'm giving you. It's not in your book. We know cashews are $10 a pound. And what we don't know is how many almonds she can buy and how many cashews. So think in algebra, how do we represent things we don't know? We use variables. So that's what this example here is going to do. We don't know how many pounds of almonds we can buy, so we can represent that with an x. We don't know how many pounds of cashews we can buy, but we can represent that with a y. And we can replace our a and b with the price of the almonds and the price of the cashews, because it's going to be $8 per almond. Think about it like you're literally checking out at a store, and then we have to add $10 per cashew pound, but we need it to equal $40 because that's how much money we have. So this is what standard form is really good for. When you have things like costs you are comparing and you don't know how much of the things you can buy, we use variables to represent what we don't know. And now we've just created an equation to represent, I can buy some number of almonds for $8 each, plus some number of cashews for $10 each, but it needs to equal $40. And since we're discussing this mathematically, we do not put the dollar signs in our equation. So let's look at your example that's in your book, and it asks us, how does the equation change if Tamara has $60 to spend on a mixture of almonds and cashews? And you can see I've marked out the rest because we're not going to mess with it. Well, if we're following this example, if she now has $60 to spend, that changes this number here. So it would still be $8 per pound of almonds, and we would still have to add, because we want to total how much money we spend, $10 times a pound of cashews. But instead of we needed to equal 40, if we had $60 to spend, it could equal $60. So there we go. There we set up that equation. When you go to do your practice, when you're thinking about these problems, just remember that the x and the y represent the pieces you don't know. Like, we did not know how many pounds of almonds and cashews we could buy, but we did know that almonds was $8 a pound and cashews were $10 a pound. And it'll tell you in some problems which variable to associate with which unknown piece of information. The last example we're going to do for this section is actually in the practice and problem solving. It's number 33, and it tells you to write each equation in standard form. So first, let's look at the equation that is number 33. It's y equals 4x minus 18. What format is that? Well, if it's a y equals by itself, it's in slope-intercept form. So we are in slope-intercept form, and we want to go to standard form. So we're in slope-intercept form, we want to go to standard form, which is ax plus by equals c. So notice we have all the pieces. We've got a y term some y, we've got some x, we've got some constant, we've got an equal sign. We just need to rearrange it. So when you take little notes off to the side, if you can, just take a little note that we need to get x and y on the same side, because that's how they are in standard form. X and y are on the same side with the numbers in front of them, and then our constant term that doesn't have a variable is the one that gets to be on its own. So we have the equation y equals 4x minus 18. And now we've determined what we need to get by itself. We need to get that constant term by itself. We want the constant term to be alone on the right-hand side, and we want the x and the y on the left-hand side. So if I'm looking at my equal sign right here, I need to get this minus 18 by itself. So that means if I want the minus 18 alone, I'm going to have to move this 4x. And let's think about what we learned about solving equations. If I want to get that 4x by itself, it's a positive 4x. How can I undo that? I can subtract 4x from both sides. And now those x and y's are not like terms, so I cannot combine them. But standard form tells me that the x term comes before the y term. So I'll have minus 4x plus y, because that was a positive y, it wasn't negative, equals negative 18. So let's check. We have the x and the y together equals a constant, something x plus something y equals something. Looks like standard form. But what did we learn on the very first part of this video about standard form? This leading number can't be negative, and right now it is. So we just have to ask ourselves, how can I undo that? How can I make that a positive? I can flip its sign, but if I flip one sign, I have to flip all the signs. I have to do that with everything. That's actually technically called multiplying by -1, but that would give us a positive 4x, so that went to a positive. That plus y is going to become a minus y equals, and then that negative 18 will become a positive 18. So we just flipped all those signs around. We didn't have to change the numbers dramatically or anything. If we just change the sign of each part, now our leading number is positive, which is exactly what we wanted, and we are in standard form. 4x minus y equals 18. Check. And that is 2.3.